Find the area bound by the curve f of x equals 3x squared minus 3 and the x-axis over the interval 0 to 2. And the graph is shown for us. So as you can see, we've got area that's above the x-axis, which occurs from x equals 1 to x equals 2. And we've also got area that's below the x-axis, and that occurs between x is 0 and x is 1. So we need to take that into account when we're setting up our integrals to find the area. So all up, we can calculate the area is going to be equal to, and we have the integral between 1 and 2 for our function, which is 3x squared minus 3 with respect to x. And then to take into account that the definite integral for a part of the curve below the x-axis is already negative, we introduce another negative sign to make that value positive. So we're going to subtract away the integral between 0 and 1 for the function, which is again 3x squared minus 3 dx. And all up, that should give us the area under the curve. Our function has an antiderivative of 3x squared, and we add 1 to the power and divide by the new power, which just leaves x cubed. And then whenever we've got the constant, so minus 3, we reintroduce the variable, so we have minus 3x, and we're going to evaluate that between 1 and 2. And then we do the same thing for our area that's under the curve, so we subtract away the antiderivative, which was x cubed minus 3x, evaluated between its terminals, which was 0 and 1. So to complete this, we know that our fundamental theorem of integral calculus says that we can simply find f of 2, which is the antiderivative evaluated at 2, and subtract away the antiderivative evaluated at 1. And then the same for our other piece of working, so we can have our antiderivative evaluated at 1, subtract away the antiderivative evaluated at 0. So substituting 2 into our antiderivative, there's going to be a few brackets. We're going to have 2 to the power of 3, subtract 3 times 2, and then we subtract away 1 to the power of 3, subtract 3, and that's the blue done. And then we need to do the same thing in our pink color. So we substitute in f of 1, which is going to be 1 to the power of 3, take 3, and then we subtract away from that 0 substituted in, so we're going to have 0 to the power of 3, subtract 3 times 0. And now we just need to simplify that down. So for the blue, we've got 2 to the power of 3 is going to be 8, and then subtract 3 times 2 is 6. Subtract, and that's going to be 1 to the power of 3 is 1, subtract 3. And then in the pink, we're going to have subtracted away, and then the first bit is 1 to the power of 3 is 1, minus 3. And then subtract off 0, take 0. So if we clean that up, we get 8 take 6 is 2, minus, and 1 take 3 is negative 2, so the negative 2 becomes positive 2. So in the blue we've got 2 plus 2, and then away from that we subtract, and that's going to be negative 2, and then we've just got take 0, so we don't have to worry about that. So we have 2 plus 2 subtract negative 2, which is the same as 2 plus 2 plus 2, which equals 6 units squared. So that there is the area under and above the x-axis, or the total area between 0 and 2 for our curve f of x.